Thank you very much. All right, thank you all for coming. Like she said, my name is Tyler. I've lost my thing here. Oops, somehow we ended up not on the starting slide. All right, we'll start here. Link there to the slides if you're curious. There'll be another one at the end, so you can look back if you'd like. So yeah, welcome to my talk. What I'm going to be covering today, the title ended up getting changed somehow. This was intended to be deploying agentic AI in the modern enterprise, but that's okay. What are we here to talk about? Well, I'm here from Redpanda. We've historically been a streaming infrastructure company. We build Kafka-compatible stream processing system, plus have a suite of 300 plus connectors that fuel some of the largest mission-critical data workloads in the world. From, I think a good example that's always sort of relevant every time I'm in New York, the New York Stock Exchange has a feed of all of the trades that are happening across all of their exchanges. That is all powered directly by Redpanda. So if you buy into that and get the real-time feed from them, it's all feeding directly through Redpanda. So we give the lowest latency, highest throughput, and sort of best efficiency that you can get for that. Going forward, we're really steering the company towards agentic. We believe that agentic AI is going to be hugely important. I'll, of course, talk more about this in the talk. But what we're building out now is building on our streaming foundations and building what we're calling the agentic data plane, which is really a data access and governance layer for agents to enable and allow agents to be deployed safely in the modern enterprise, in your private networks, on your private data. I'm not going to go deeply into this. This talk isn't meant to shill what we're doing, but it is to give you sort of context. Most of what this talk is going to do is explain to you kind of where I've been coming from of why a company like us is actually in a really good position to build something out like this. But even if you don't go with something like the agentic data plane, I think the ideas I'll talk about can be useful as you think about how you might want to deploy agents in your own enterprises, regardless. Who am I? Where am I coming from? Apparently it's hard to load images, so none of that's there. The point of this is mostly to say that I've been doing streaming for close to 2 decades now. I'm just going to pop out and see if we can get it to reload. There we go. Technology's hard. I've been doing streaming for about 2 decades now, and I've been doing AI for a hot year if you round up. So most of where I'm coming from is someone who's sort of been doing streaming, looking at what's going on in the agentic world as we build our stuff out, seeing what companies are doing, and this talk really is kind of me looking at it and saying, streaming actually has a lot of applicability here. So this is going to be the agenda for the talk. We only have 20 minutes here, so I'm going to be rushing a little bit. That's okay. Start out talking about what agentic AI is. I will actually buzz through this very quickly. You're all here at an AI conference. I assume you know what this is, but this talk is sort of crafted for a broad audience. So bear with me. I'm not trying to talk down to you. Talk through the opportunity a little bit. I think the most interesting parts of this talk for this crew are going to be the challenges and then the ways that streaming can help with agentic AI. So real briefly, what is agentic AI? I usually refer people who don't know what agentic AI is to this Anthropic article. It's a nice place to start. They kind of describe the differences between what agents are in general, their take on agents versus workflows. Personally, I don't really care agent versus workflows. If I'm going to say agent, I'm really referring to some sort of system that's using AI as some sort of autonomous system, whether it's orchestrated with workflows or it's an agent given a prompt and told to run on its own, just so you know where I'm coming from. It is useful, though, to kind of highlight a simplified view of what an agent is. At the core, it's an LLM. It's getting some number of inputs in, making some number of tool calls. I think at this point in time, most of the time this is happening through something like MCP, but you can do it directly to databases and systems, whatever. And then there's some outputs coming out. It's nice to have this diagram because if you're looking at it, you can already kind of start to see why streaming may feel relevant in this space. Like this looks a lot like actor-based streaming systems that have existed for a few decades. So the opportunity, again, I'm sort of preaching to the choir at an AI conference. So AI has materially changed the way that we live. We believe this is going to be true for business. The really important point to make here, before we jump into challenges, is, my bad. We believe every business interaction will be mediated by AI sometime in the near future. It's not a question of not a question of if, but it's when, how, or who. But more interesting on the challenges side, if you look at the consumer AI market, it's flooded. But I would make the argument, and many like Gartner have made similar arguments, that agentic AI in the enterprise is foundering. It's really had a hard time kind of getting off the ground. Agents are super easy to build, but actually deploying them in your private networks on your private data still feels hard. Why is that? So to start out with, I like to do this. Again, this may feel sort of obvious to some of you, but I'm going to go through this because I think it does help frame things. Also, I get to talk about Dungeons & Dragons. Have any of you ever played Dungeons & Dragons? 7, that's not bad. That's not bad. The very first time I gave this talk, I gave it to our sales group at Redpanda, and I thought for sure to get 0 hands. I got like a quarter of the room, and then every tech conference I've gone to after that, I'm like, surely it'll be better, and it's been like crickets, like 2 or 3. So I'm glad that we have like 7 in here. So in Dungeons & Dragons, they have these things called alignment grids, which is basically a 9x9. If you plot it out, it's a 9x9 grid like this. And the idea is that you've got 9, or 3x3, excuse me. You've got 9 different personality types that kind of help you understand where a character might be coming from. So from left to right, it's lawful to chaotic. So lawful is you follow rules. Chaotic is you do whatever you want. And then from top to bottom, it's lawful down to evil. Good to evil. Good being selfless, altruistic. Evil being selfish, malevolent. The point of this is it's nice to think, when you think about agents, we're basically wanting to bring them on as digital employees. So first, think about what do we do when we bring on human employees? Well, a human employee or a human candidate shows up. They've already spent their life with a bunch of schooling, a bunch of probably previous jobs unless they're fresh out of school. They have this big resume they built up. We spend a ton of time talking to them about, what are things that you've done, getting a sense for, are their skills actually there, but also importantly, like are they a good culture fit? Do they seem like a person who's going to do the things that they say? Can they deliver? And then there's these other sort of intangibles, like you exist in modern society and you're not in jail, so you're sort of willing to follow rules to some degree, right? What we're really trying to do in all that is both match skills, but also make sure that you kind of fall into this. We're kind of aiming for lawful good. Realistically, most human employees, I think, fall somewhere in this top left quadrant. And like I was at Google for 12 years, and we had a lot of chaotic good folks there. That was fine too, but generally they're going to be here. So what's interesting looking at agents and why they are tricky, like to me this is the core reason why agentic AI in the enterprise has struggled, is that agents today at least, they fall squarely in that chaotic column. The model companies are like pushing really hard to get them up to lawful good, and maybe they're getting up towards chaotic good, but you really, they're highly unpredictable, and it's really hard to know what they're going to do. And this really is sort of the crux of the challenge of enterprise AI, in my opinion. So more concretely then, there's a whole bunch of things that go into successful agentic AI in the enterprise. Agents need context. So you need to build up that context for them, and you need to maintain it over time. Maybe that's just giving them access to a system, but maybe like you already do for a bunch of your human employees, this is ETLing data in, doing a bunch of analytics on it, or doing sort of pre-joining of data, preparation of data sets. There's a whole bunch that goes into saying, I've got the data sets that these agents need so that they can work effectively. They need to be able to query that data. Whether that's running SQL queries on it, making RPC calls into systems, things like that. You need auth. You need to have identity for what agent is this. Particularly given that agents are so easy to replicate, you need to know this is a given instance of an agent, and it's allowed to do a certain thing, which segues into governance. Governance is important. Once you know who the agent is, you also need to know what is this agent allowed to do. What data are they allowed to read? They make some decisions. What data are they allowed to write, or what actions are they allowed to take? Or do they always have to interact with a human to sort of have validation, or do you have other agents validating them? Once you have an agent in place, you really need to be able to audit what they're doing. You can't debug an agent. You can't go into it and be like, well, where's the if statement that made it do the stupid thing and give away a car? The best you can do is essentially, flight recorder style, record everything that goes in, everything that they sort of ask about, and everything that goes out, trace it all, and be able to go back and query that, analyze it after the fact, and say, okay, it did something amazing here or something awful here. What made it do that? Very related to that, as you're developing new agents, you want to be able to compare to previous agents that you've had. And again, really the only real way to do that is to say, well, I've got some either synthetic test data or some real-world data that we've recorded. we know what happened with the old agent. Let's try it with this new agent and see how it goes. See if it does as well or better. So replay and validation play into that very heavily. And then as you build more complex systems with agents, you're going to find there's a whole lot of data routing or communication that happens, as well as multi-agent coordination. This isn't an exhaustive list of what you need for enterprise AI to be successful, but you at least need all of this stuff. It's a reasonably decent list. And so the sort of epiphany I had as I sort of started digging into this stuff at Redpanda earlier in the year was, a lot of these are actually data streaming problems. Or if they're not a data streaming problem intrinsically, they're actually really well solved by data streaming. So that gets us into the last part of the talk, ways that streaming can help. So I'm going to walk through each of those briefly, some more briefly than others. So context building and maintenance. This one should be sort of a no-brainer. Like this is just classic streaming ETL use cases. Maybe you're streaming into a vector DB, or you're streaming something into an OLAP store. You're doing some sort of transformations along the way. Maybe you're doing the sourcing, chunking, embedding along the way, whatever. No one's going to argue that this is a surprise. Like streaming is super valuable here, so we'll move on. Governance, though, I think governance is probably the more interesting one. So governance doesn't need to be a streaming problem, right? But if you think about sort of in the limit what you want with agents when you're deploying them into your enterprise, just as today your human employees in aggregate touch all of the private data within your enterprise, you're going to want to get to a world where your agents in aggregate, not any one agent, but all of them sort of combined, are going to be touching all of the data within your enterprise. But you're also going to really want to be sort of safeguarding those accesses, understanding what the policies are that allow them to interact with the data, and you're going to want to sort of do that uniformly. And so you kind of have two options. One is you can manually apply those at all of these different data sources across the entire enterprise. And that's fine, but conformity gets to be a bit of a challenge. Uniformity is tricky. And if you think of a large modern enterprise, we're talking thousands of systems at this point. If, on the other hand, you're using a streaming system to act as this sort of communication interconnect between these data sources, these systems, and agents, both on the input and the output side, that system then naturally becomes a place to enforce uniform governance policies across your agentic fleet. And so that's why streaming actually, somewhat to my surprise, does become a really good place to enforce governance. Another place where streaming fits in really nicely is this auditing, as well as replay and validation side. As I said before, LLMs are opaque. You can't introspect their internal logic. And so if you want to make sense of their actions, you've got to basically look at the I/O. What agents bring to the table that's different than what we've done historically with auditing is, classically, auditing has been metadata focused. Tyler accessed table X. You didn't record everything that I pulled out of table X or the results of the query. But with agents, you really want to, because otherwise, you're flying blind if you don't know everything that's going in and out. And so you're really stepping up auditing from being a metadata recording operation to a full-blown data recording operation, which means you've got a lot of data to record and you want to do it with low latency and high throughput, which again is a thing that streaming systems have been developed to be really good at over the last few decades. Also, by recording it in one of these streaming systems, you naturally then are able to replay it and run it through for validation or for sort of replicating these systems across various locales, things like that. Another use case where streaming falls into place is the world of dynamic routing. So if you think about agents, they're kind of a big hammer that solves a certain type of problem, but they're not really practical to apply everywhere today. So a good example is fraud detection. If you think about how companies have been doing fraud detection for the last decade, there's been a huge amount of investment into ML training and ML inference, right? Companies can build up these ML models that can give you a pretty good ability to reason about fraud or spam or things like that, and run at fairly large scale. Now, if you bring a well-trained LLM agent into the picture, they can probably do a better job than the ML model in some of those sort of trickier use cases, especially if they're able to access additional context beyond that which is provided to the ML model. But if you think about the agents are more expensive, they run more slowly, and so in general, you couldn't just take an LLM agent and shove it in front of that massive pipeline that you were running your fraud detection or your spam detection in front of and expect it to succeed unless you really have a ton of money to throw at GPUs and sort of scaling this up. And so what happens, or sort of the right approach to take in those sorts of scenarios is keep your existing ML model-based pipeline. It's fantastic. Maybe you tune it down a little bit, so instead of, maybe you be a little less aggressive and say, we're going to let a few more false negatives through, things that we think we're not sure if they're fraud or not. So rather than being like, well, we'll just go with it because we don't want to make the experience worse for users, it's okay. Let a few more of those through, but all of those negatives, which is a substantially smaller amount of data than the very clear positives that you're letting through, send all of those to an LLM, to a fraud detection agent, and let it do the more complex, more thorough check on it, and then let it pass things through, whether it's allow or deny. So again, being able to do all this coordination through streaming systems just very naturally makes it so that you can keep these systems separate, you can deal with outages and all those sorts of things. And then relatedly, multi-agent coordination. It's a very similar sort of scenario, but one of the things that we've noticed with customers and people we've talked to who are building out successful agents within their enterprises is this notion of basically having suites of agents working together. For example, here, you might have some agent that's making some sort of decision on behalf of a customer, and then it's going to propose, well, here's my solution. You can just go with that, but just going blindly with what the agent proposes is kind of a recipe for disaster, given how chaotic that they are. You can have them be fully human in the loop and say, well, human always has to audit the decisions, but that's not going to scale as large as something that's automated. So a nice kind of middle ground is using Sentinel agents, where you have additional agents that you've deployed, and their role is to look at the proposed solution and sort of give a thumbs up, thumbs down on it. And we even had one customer who was really concerned about basically the idea that you can sort of send these poison pill prompts or queries or inputs into LLMs and make them make bad decisions, or they'll sort of let stuff through. So they actually had it set up where they had 3 different validators set up, each running a different LLM. So maybe one was Ollama, one was going to OpenAI, one was going to Anthropic or whatever, just throwing some names out there. But like basically, you set up a suite of validators, and you need, say 2 out of 3 or all 3 have to give a thumbs up before you allow this thing through. They found that for that use case, they went from being like kind of 90% successful, which was not really going to be practical for it to be fully automated, to multiple nines of success, to the point where it's like, that's fine, that's good enough. Like we're really not going to do better with a human, but the thing's fully automated. And again, when you're sort of tying all this together, a streaming system like Redpanda ends up being a really useful tool for doing all of this. At the same time, I like to kind of close the talk out and highlight, like, I'm a guy coming from a streaming background, working in a streaming company who's building out now agentic infrastructure, but streaming isn't everything. And if someone's telling you, all you need is streaming for agentic AI, well, they're just really trying to shill you what they're building. There's a whole bunch of other stuff that goes into it around auth, catalogs from contextual data, querying, durable execution for workflows. If you're building workflows, you name it. There's a lot more to it. But still, streaming is a shockingly key foundation to building out one of these agentic data planes, and it's something that you should keep in mind as you look for, how am I going to deploy agents in the modern enterprise? And with that, I can even end early. Time for questions.